Hey you guys, this is Mr. Millings, and today we're going to learn about type 1 binary ionic compounds. We're going to learn how to name them, and we're going to learn how to write the chemical formulas for them. So what is a type 1 binary ionic compound? Well, let's break this down here, people. First of all, we learned in an earlier video that a compound is two or more different elements chemically bonded together. And what does it mean to be ionic? Well, anytime you're ionic, you're going to have a metal bonded to a nonmetal. Okay, so we have a compound, one of which is a metal and one of which is a nonmetal. And the fact that it's binary, the prefix bi just means two. So we have a compound that consists of two different elements. And the fact that it's type 1 right here means that the metal comes from either groups 1 or 2 and is either silver, zinc, or aluminum. So anytime you have a metal that comes from groups 1 or 2 and is either silver, zinc, or aluminum, and it's bonded to a nonmetal, this is going to be a type 1 binary ionic compound. So let's take a look at a couple of examples. If we take a look at this example here, lithium chloride is a type 1 binary ionic compound. Why? Because we have a metal and we have a nonmetal. Right? We only have two different elements here, lithium and chlorine. One of them is a metal and one of them is a nonmetal. And specifically, this metal here comes from group 1. Okay, so anytime you have a metal coming from group 1 or 2 and is either silver, zinc, or aluminum, and it's bonded to a nonmetal, it's going to be a type 1 binary ionic compound. Same with calcium nitride. Okay, calcium comes from group 2 on the periodic table. It's bonded to nitrogen, which is a nonmetal, and so bam, you end up with a type 1 binary ionic compound. And in this video, we're going to learn how to name type 1 binary ionic compounds, and we're going to learn how to write the chemical formulas for type 1 binary ionic compounds. So let's jump right in with a few example problems. Alright, so let's learn how to name type 1 binary ionic compounds. So what if you're given the chemical formulas for a binary, or specifically a type 1 binary ionic compound? First of all, how can we tell that all of these chemical formulas here represent type 1 binary ionic compounds? Well, we can tell, first of all, because we have a metal bonded to a nonmetal, and every single one of these, right? In every single one of these, we have a metal bonded to a nonmetal, and keep in mind that the most electronegative element gets listed first, and so this is why Be comes before F. And so we have a metal bonded to a nonmetal, metal bonded to a nonmetal, same thing here, same thing here, same thing here. And specifically, the metal that we're looking at comes from groups 1 or 2 and is either silver, zinc, or aluminum. So we have a type 1 binary ionic compound here, and when we name these, it's pretty simple. It says right here that when naming a type 1 binary ionic compound, simply name the metal followed by the nonmetal with an IDE ending. For example, the metal here is called beryllium, right? It's beryllium and it's bonded to a fluorine atom. Well, when we're naming this in a type 1 binary ionic compound, we drop the "ene" and add an IDE suffix. So this right here becomes beryllium fluoride. This right here would become sodium chloride. This right here would become zinc bromide. This right here would become lithium oxide. This becomes magnesium sulfide, and this is calcium phosphide. Okay, so the first thing you have to do is first be able to determine what type of compound it is. We're going to learn about type 1, type 2, type 3 compounds. And so you first need to be able to determine that this is a type 1 binary ionic compound, and follow the rules for naming these compounds that you see right here, and you should get it right every single time. But what if we're working the other way? What if you are given the name and you're asked to write the chemical formula? Well, let's take a look at that. Alright, so what if you're given the name of a type 1 binary ionic compound and you're asked to write the chemical formulas? So for example, we are given the name sodium bromide, but we want to write the correct chemical formula here. How does that work? Well, it says right here, when writing the chemical formulas for type 1 binary ionic compounds, we're going to have to add subscripts to each atom in the compound so that the ionic charges of the two different atoms adds up to 0. So whenever we have a metal bonded to a nonmetal, the ionic charges always must add up to 0, and that's an important concept. And so what we have to do is we have to add subscripts to the elements in our chemical formula to get those ionic charges to add up to 0. For example, sodium, we know, comes from group 1 on our periodic table of elements, so all those have a positive 1 charge. Bromine or bromide comes from group 17 and it has a -1 charge. So if we take a look, we have a +1 charge here and a -1 charge here. These two charges add up to 0. +1 and -1 add up to 0. And so we don't need to add any subscripts here. And so our chemical formula for sodium bromide is just going to be NaBr. Let's take a look at this one. If we take a look, rubidium, the chemical symbol is Rb. And the ion forms +1 ions because it comes from group 1 on the periodic table. Sulfide comes from group 16, and so it forms -2 or 2- ions. And so if we take a look here, this charge and this charge do not add up to 0. +1 and -2 do not add up to 0. But if we have another rubidium ion here, +1 and +1 is now going to add up to +2, and this +2 charge is now going to cancel out the negative charge over here. So how do we show that there's two rubidiums in a chemical formula? We do that by writing a subscript that we see right here of 2. Okay, so the correct chemical formula here will be Rb2 and just one little sulfide. So Rb2S will be the correct chemical formula. If we take a look right here, magnesium nitride, we know magnesium forms +2 ions or 2+ ions, and we know nitride is N-3. These two charges don't add up to 0, so it looks like if you have 3 of these, the total charge will be +6, and if you have 2 of these, the total charge will be -6, and they add up to 0, and so that's why we get Mg3N2. Alright, and that's why we get silver phosphide being Ag3P here, because silver, you're going to have 3 of these, all containing a +1 charge, and you're going to have phosphide, which is a -3. The +3s and the -3 ends up adding up to 0, and so we have Ag3P here. So let's take a look at a few examples and see if you can get some of these correct. So when you write the chemical formulas, you're going to need a periodic table. So we have one right here. We have to write the correct chemical formula for sodium chloride. We know sodium is a +1 ion, and we know chloride is a -1 ion. These two charges add up to 0 already, so you don't need to add any subscripts. The correct chemical formula is going to be NaCl. Let's take a look at another example. In this example here, we're asked to write the correct chemical formula for calcium fluoride. Calcium comes from group 2 on our periodic table, and all these form +2 ions. So calcium is +2, and then we have fluoride over here. All these halogens here, they form -1 ions, and so here we go. These two charges do not add up to 0, but if we have a second fluoride, then the total charge here will be -2 on the right hand side, and the total charge here will be +2. So what will our chemical formula be? It's going to be CaF2, right? There's 2 fluorides indicated or represented by the subscript of 2 right there. So CaF2 is the correct chemical formula for calcium fluoride. Let's take a look at another one. Okay, so let's write the correct chemical formula for beryllium fluoride. We know beryllium is in group 2 on our periodic table, and it forms +2 ions. If we take a look, we see that phosphide is in group 15 on the periodic table, and these guys typically form -3 ions, right? And so if we take a look, the lowest common multiple of 2 and 3 is going to be 6. So how do I get this to be a +6, and how do I get this to be a -6? I'm going to need 3 of these. I'm going to need 3 berylliums, and I'm going to need 2 phosphides, right? So if we take a look now, the total charge here is +6. The total charge here is -6. These add up to 0. So we end up with Be3, P2 as our correct chemical formula here. Let's take a look at another example. In this example, we're asked to name this compound right here. We can see cesium comes from group 1 on the periodic table, and it's bonded to a nonmetal, right? So we know this is a type 1 binary ionic compound because the metal comes from group 1, and so when we name this, this is just going to be cesium fluoride. Cesium fluoride will be the correct name for this compound here. Let's take a look at another one. Alright, if we take a look at this, we have to write the name for Ca3P2. Once again, we have a metal and we have a nonmetal here. So this is an ionic compound. We know that calcium comes from group 2 on our periodic table, so this makes this a type 1 binary ionic compound. And so when we name this, we follow the rule. We just call this calcium, and then we change the ending of phosphorus to an IDE ending, and we get calcium phosphide. Okay, let's take a look at one more example. All right, so if we take a look, AlBr3, AlBr3, the correct name of this is going to be aluminum bromide. Aluminum bromide, right? Aluminum is a type 1 metal. It only forms positive 3 ions, so it's a type 1 metal. It's bonded to a nonmetal, so we name the metal aluminum. We change the ending to "ide" and we get aluminum bromide. So now that we worked through some example problems, try these. What I would do right now is pause this little video and try to fill this table in, okay? Try to figure out the chemical formula for sodium phosphide. Try to figure out the name of this little compound right here. Try to write the chemical formula for strontium fluoride. Pause this little video. Take about 5 minutes to try these on your own, and I'm going to give you the answers right about now. So here are the answers. How did you do? Hopefully you got them all correctly. You got 100%. If you like what you see, go ahead and click that little bomb in the bottom right hand corner. That will subscribe you to my channel. And feel free to leave any comments or questions in the comments section down below. And I hope you guys found this helpful.